Going to learn about convolutional neural network, which is part 3 of our AI technique series. In our last class, we studied about multi-layer perceptron network, MLP. So, before jumping into CNN, we will look at the practical applications of MLP, which is multi-layer network. So see, this multi-layer perceptron networks are very useful in stock pricing and weather pattern forecasting. So usually in forecasting task, what is used is the historical pattern, the historical data. So the model would read the pattern from the historical data, which is time series data or temporal data, and predicts the features. These MLP models are used in stock price prediction and weather pattern predictions. And next one is regression tasks. These MLP models are very useful in house price prediction and sales figures prediction. These are all related to regression task. In regression task, the continuous variable, which is the prediction variable, will be the target variable. The model will predict the target variable based on some independent factors, influencing factors. Those are all called as X variables. So these models, MLP models, would learn the patterns from those input data and then come up with predictions. And the MLP models are used in house price prediction and sales figures predictions. And next we will see the usage of MLP in classification task. These MLP models are used in spam detection and fraud detections. So these are all called as classification models. Before the era of AI, the spam detection was done using a rule-based engine. The rule-based engine will use some keywords and then identify the spam mails and quarantine. But with the help of this advanced AI techniques, these MLP networks are come up with that more intelligent methods. It understands the pattern in the spam mails and then it automatically quarantines those mails. And these models are very useful in fraud detections as well. So this is that fraudulent activity is very common in finance industries. Example is fraudulent activity with credit card transaction, debit card transaction, and check transactions. So those fraudulent activity can be filtered out or avoided by this AI-based models. And next one is recommendation system. These ML models are very useful in learning the customer behaviors. So we do have a lot of social media content. Those contents were learned by these NLP models, and then it's very useful in defining the scope of the customer. That means unique customer experience it gets. It recommends the products and content very specific to the customers. It's very useful in promotional marketing of any products, and also when we look at the movie, that Netflix, it's very useful in recommending the movies which are very interesting to unique customer. So it gives better customer experience. Now we will move on to the convolutional neural network. The convolutional neural network, which was demonstrated by the researcher Ian Lincoln during 1989 at AT&T Bell Laboratories, and he used this convolutional neural network model for handwritten digit recognition. Even before that, some researchers introduced this network. Earlier time, this convolutional neural network was not named as CNN, but later on, this networks gained the popularity, and more research have been done using convolutional neural network. Just let us see how this architecture looks like. This is multi-layer perceptron network, and we have already studied how this MLP network works. And we look at the architecture for convolutional network. This is very innovative idea, how the network is architectured. So this is very powerful in reading the image and learning the patterns from the image. So we don't need to get confused by looking at complete architecture. We'll go through one by one about the building blocks of this CNN network. And we look at that building blocks of the CNN network, and it has four different components. One is input image, second one is convolutional layer, third one is pooling layer, and last one is fully connected layer. Input image. So this is the first building block. Input image, this layer is created to just represent the given input image. So the input image could be either black and white or color. So when it is a black and white image, it's in grayscale. So we need to have only a single layer. The pixel size of this layer might be equivalent to the pixel size what we used in the data. And the value in this each neuron represents each pixel in the given image. Usually the range varies from 0 to 255. But in the case of color image, so we need to have three layers. One layer represents each channel in the RBG color channel. So one would represents red, second layer would represents blue, and third one would be representing green. So we will have three layers. When we represent this image, we also add some kind of padding. Padding is like just how we frame our photo. So we would be having our photo, and we will be adding some padding at the edge of the photo in order to preserve or preventing the photo from getting damaged at the edges. So it's another example could be building a compound wall in our house. So next we will move on to convolutional layer. So convolutional layer is a kind of filter which we call it as a kernel. This kernel extract the information or feature from the input image. So it's a kind of feature extraction mechanism by using layers or using filters. Those filters are called as kernels. These filters convolute over the given layer and extract information and then generate next layer, next convoluting layer. So during the convolution process, it extracts information. So during the initial layer, it extracts very simple geometrical shapes like line, curves, and some straight line or some kind of shapes it learns. It's all what type of information it learns is based on the type of kernel we used at each layer. The next one is once the information is extracted, it generates next layer, and then we move on to another type of building mechanism which is called as pooling layer. So pooling layer is the analogy that what we can say for pooling layer is the compressing the information and then reducing the size of the layer when we move forward. So this is very important when we want to reduce the computational task. This is just like zipping a file. So when we want to move the file or reduce the file size, we use zip and then unzip later on. So similarly, the pooling layer is applied and it reduces the size of the next layer. So now we know that input image, read the information from the input image, and there would be RBG channel, and then we apply kernels. The number of kernels depends on the complexity of the image, what we want to learn, and the type of pattern we want to learn it from the given layer. So this convolutional layer convolutes on the given image and it generates a next layer. So this is a kind of dot product by just mapping this kernel against this given layer. And pooling layer, it compresses the information and reduces the number of neurons in the next layer. And next one is fully connected layer. In the fully connected layer, we know how the fully connected layer networks. There are independent neurons which are fully connected to the previous layer, and it reads the information from the previous layer, pooling layer, and it extracts very complex information, and then it is specified to do a given task. It could be classification or predictions. So when we put together all those building blocks, this is how our neural network works. So let's first look at our image representation task. In this image representation task, here there are three channels, RBG channels. Already I said that its values varies from 0 to 225 for each of these channels. And also we would add padding. Padding means just add additional dummy layers. Usually the values would be either 0 or sometime it would be the value at the edge of this layers. This padding is added in order to prevent the information loss during the convolution process or pooling process. So next we look at the convolution process. During the convolution process, this is the filter. The pink one is the filter. This actually convolute on this given layer, and then this it's a kind of dot product between these kernels, and then this it's a kind of slicing the 2D matrix from the given layer, and then doing dot product between these two-dimensional matrix, and then generate this next layer, which is convolutional layer. And next one is when we do the convolution with three filters, this is what it does. It's actually the first filter convolute on this first channel, and the second kernel convolutes on the second layer, second channel, and third one is convoluting on third one. Each one is doing its own dot product and then generating a 2D matrix, and these 2D matrix, three different 2D matrices are combined together, and this is the output of the combination. And this is how the convolution process works. Out of convolution, we get the final 2D layer, which is the next deep layer, which would have the abstracted information from the previous layer. And see how the feature extraction works. So this is the input image. The convolution happens on this image. During the convolution, this kernel convolutes on this image, and it learns the edges and simple lines and polynomial stuff, and then create a feature map. This is the layer created from this input image using this convolution process. This is how it preserves the information from the given image or learns the edges and lines from the image. Next one is pooling. So see how the pooling works. Pooling is actually compressing the information. Now we are using 2 by 2 matrix for pooling. So what happens is either we can take the maximum of this 2 by 2 matrix. In this case, in the first 2 by 2 matrix, the maximum value is 6. So this is the convolutional, this is the layer after pooling. The pooled layer value of this first neuron is 6, which is max of this 4 values. This process is called as max pooling. So instead of max pooling, we can also take average value or mean, or whichever is relevant to our given task. So during the pooling process, we compress the information and create a lower dimensional space compared to the previous layer. This is helping us to train the network faster and make the convergence faster. This is how the pooling works. So see the animation diagram. And what is intuitively happening after this pooling as well as the convolution? So this is how the informations are extracted. So this is a given pixels, the input layer, image from the input layer, and then during the first convolution process and after pooling, these are the edges detected from the given images. So that network learned all this abstract information, lines, and then at next level it learned the abstract next level of abstraction, which is actually kind of recognizing features and learning features, just like learning eyes, or nose, ear, or hair color, or some additional next level abstracted information. So this then when the deep convolutional layer at next level, it started learning object models. It started recognizing face itself. This is a more abstracted level of information. So when we add additional deep layers, it started learning more and more abstract features, more and more details in the given image. The analogy that I can quote here is a painter who starts drawing an image or drawing a human face. What he would do, that he would do initially start with just sketching a line, just sketching the eye lines or face lines or contour of the given human face, and then after some time, maybe after half an hour later, if I go back and see the painting process, I would started seeing the nose, more detailed information like nose, eyes, mouth or neck or some additional level of information, but the entire image is not yet completed. Then after 2 hours, when I go back and see that picture might be very looking elegant, it may have a complete human face, but it may not be more polished or more elegant. Maybe after 2 days or 3 days, it would be very complete, and it completely shows us a picture. That means complete abstracted or complete more realistic image of a given photo. This is how that this is analogy that I can quote here also. It learns edges, objects, parts, and then more complete information. And finally, we can add fully connected layer at the end to classify what the image is. And now we can understand this network more clearly, how it looks like. So this is the input image. It learns image from the input data, and then this is a convolutional process or convolutional layer. This next one is the pooled layer. Again, there is a convolution happening, and again there is a pooling process happening, and finally we have a fully connected layer. This fully connected layer would predict the intended task. Next, we will see the practical applications of convolutional neural network CNN. So one of the very classical example is image classification, where the model can classify whether the given image is a dog or cat. So this is very powerful in image classification. Next, it is being used in object detection. So when we have a given image, it easily can detect objects from the given image. So this convolutional networks are very useful in object detection. And third one is facial recognition. So it's very useful in recognizing a face, and which is these facial recognition softwares are very useful in our mobile or any security system where the software is protected by facial recognition. And next one is medical imaging. The CNNs are very powerful in doing advanced medical imaging. And next one is, this is very useful in object segmentation. When we look at a given picture, the complete picture, this image, the CNN are very powerful in detecting, differentiating or segmenting grass, trees, or human being or animal from the given image. So these are the few of the applications of convolutional neural network. There are so many applications by CNN. And so I'll stop here. We will continue our lecture in our next class. Thank you everyone for watching our lecture videos.